Welcome back to School of Civil Engineering. In our previous lecture, we have just completed our that pile cap, and we have checked everything that our pile cap is okay for punching shear value. Our pile cap is okay for pile load test. Okay, for everything it's okay. I mean, pile load test means our pile carrying capacity, load carrying capacity of pile, that are also okay. Okay, so our that pile cap is absolutely okay for our design. So now we'll go for our design. So before design, I'll just unlock it. Okay, and actually if you're new here, you can watch our previous lecture. That link are given in description. Okay, already have completed about 5 video for our pile cap design and analysis. So this is our last lecture. So in this lecture I will just show that how we'll design our pile cap. So first of all, before design, we have to just define our strip. Okay, we have to define our strip for it. So before that, we need some point here. Okay, we need some point here to define our strip actually. So for that, I'll just go ahead, draw point. That was 0.67, you know that. So for x, that was 0.67. so here just click here. Sorry, in x direction, that was, sorry, it's not millimeter actually, that was meter. So I'll just go here, change unit, click here for change unit, and from here unit. So I'll just give here Newton meter. It's okay. Then okay, that okay. Now simply click here. It's okay. Click OK now. Now go here, draw, and draw points. Now this is in meter. So give it 0.67. Okay, so here a point, and here is another, and for that side, and at middle point that is already defined. So just simply give her minus point, minus value, this is minus. So for that point here, and also that point, and after that make it 0, and give her 0.67, right, for that point and for that point. And for that point and that point, it will be minus 0.67 for that point and for that point. So we have defined our all point. So I'll just close that. Now I'll go here again, sorry, draw, then click here, draw design strip, and from here you can change that value. I just give here 1, 1, 1, and 1. Okay, I'll just consider, actually it's better to understand about that. So if we start from here, okay, then that will be the left and that will be the right. Okay, so in that side our distance was 0.67. you can give here 0.67, and at right, okay, in right we can consider 1 for it, and actually I think that will be okay. So it's 1, consider 1. Okay, and you can change that, and in my previous some lecture I have just shown you that how we'll define that data perfectly. So if you can see that from there. So from here I'll just select from that point to that point, then simply escape. So here we have defined our one line. In similar way, we have to define our wall line design strip. So actually I have done a mistake. It shouldn't be column strip. Okay, it shouldn't be column strip, or we can define that is as a column strip. Otherwise I'll just simply select that and then delete, sorry, Control Z. I'll just select that and Control delete. Okay, then again go define draw, then go here, draw design strip, and from here I'll just, for column strip, here is from that point to that point, that is for column strip, then escape, and again go draw, then draw design strip, and from this for A, and for B this is for another. Okay, it's done. Now again go draw, then draw design strip, and from here I'll select for A means direction X, and from here I'll just consider this is middle strip, not column strip. Okay, so from that point to that point, then click, sorry, Control Z, escape, I'm sorry, draw, then click here, this is a middle strip, so from that point to that point and press escape, and again draw, then design strip, so from that point to that point and then escape, and now we have to draw a strip in that direction. So from here similarly draw, just simply change that direction V, okay, strip layer, so from that point to that point, escape, again go draw design strip from that point to that point. So it's done. We have defined our design strip. Now simply we'll go for run analysis. Okay, run analysis, we have done it. So here we have done it. Now we'll go here, design, you can change the design preferences. Okay, cover, we have defined everything here, so I'll just close it. Now go here, display, here show slab design. Okay, show slab design. Also you can see the show strip forces or show slab forces, like that. So if you want to see the strip forces here for dead load, okay, so this is for moment, for layer A, this is file diagram, apply, so it's showing our value. Okay, it's showing the value, it's Newton, it's showing Newton meter, so I'll just change that data. So from here I'll just give her kilonewton meter, it's kilonewton meter, then okay, then okay. Now see here, it's showing us the moment in kilonewton per meter. Here also showing the moment in for the 3 layer. Also you can give a layer in middle for that layer moment, but I'll not provide any layer in middle because I'll provide reinforcement for that point, reinforcement in middle also. Okay, and actually this is the way to define the reinforcement. So this for moment, this for moment for layer A and B, also this is for layer and B, this is for axial force supply. So they have no axial force actually here, the shear force. This is the shear force diagram. Okay, this is a shear force diagram for that option. So actually in this way you can see that. So I'll simply go display, show slab design, and here first of all select strip base, and for layer A it's okay, okay, and area per unit. So simply it's also okay, everything, just simply click here, it's showing the reinforcement requirement. Just see here, it's showing the reinforcement requirement in, it's showing meter square, it's showing as meter square. Okay, the reinforcement requirement in meter square per meter, but I'll just change it, I'll change it the unit. So from here select the river section dimension displacement. So from here I'll just simply click here matrix default, then click OK. Then see here it's showing the millimeter in millimeter square per meter. Okay, millimeter square per meter, it's showing us the reinforcement requirement. So here we require 4000, almost 4000 millimeter square reinforcement in that point. Okay, in near column stiff, like that. So here also it's showing the reinforcement requirement, okay, from that point to that point, and also obviously select that point, impose minimum reinforcing. Okay, so simply apply, and see here it will show the requirement of minimum reinforcement for your design. So just see here, here it's showing they have no reinforcement requirement for top. Okay, for top there have no reinforcement requirement. So here also some reinforcement requirement here, I mean in that point for top. Okay, and from that point to that point they have no requirement for top reinforcement here, and here they have no reinforcement requirement for top. So layer B, I'll just close that and apply. Similarly, it's showing the reinforcement requirement for bottom, right? Here it's showing the reinforcement requirement. Here we require some reinforcement in top here, and also here the bottom and top reinforcement are showing. Now always I prefer, okay, always I prefer, before that we'll just take the finite element based method for direction 1. Everything is okay, then apply. Just see here it's showing us the direction for direction 1, top, for top river it's showing for that point there have no reinforcement requirement of top, but here we require some reinforcement for that point, and that point also, and for that point here also we require some reinforcement. And here apply for direction 1 bottom. For bottom everywhere we require reinforcement. Okay, everywhere we require reinforcement, and here we require more reinforcement, and it's showing here the little reinforcement here, here, and here we require little reinforcement here actually. So for direction 2 top it's showing the in direction 2 the top reinforcement, and for bottom actually here it's showing where how much reinforcement we required at which point actually. Okay, so I'll always prefer to use step based method, go for a step based method. Also you can go for finite element method, they have no problem actually. So after that simply go here, and from here actually this is the main detailing. Also I recommend you that if we use that point, then that will be very easy for us to make the detailing of it. So I'll just consider for top I'll consider 16 mm bar, and for bottom I'll consider 20 mm bar. Okay, and here spacing is 250 and 250. So I'll just see that, I'll just click for top river, then apply. Now see that when we have providing that arrangement, here we have no requirement of reinforcement, but here it's showing we got more reinforcement. So we'll just give her the reinforcement that is this reinforcement, so it's decreasing. I'll just give her the spacing 125 for top, apply. Now it's showing we got some little bit reinforcement here. Okay, so if we just increase 100 spacing, apply, just see here if we provide the reinforcement in top with a spacing of 100 20 millimeter bar, then our top is covered. For second direction actually sorry, here apply for second direction for top, that's also okay. But I will always recommend you use that step based method, and for layer A and for layer B. Now apply. Okay, now here it's telling us for top. Okay, I'll just give it first of all for show top river only. Okay, I will first of all design only for top river, then apply. Okay, now I will just give here 200 mm, then apply. Actually, if I give 300 mm first time, so just see here, when we have provided 300 mm at a distance of bar number 16, if we provide the 16 mm bar and in a spacing of 300, I'll just 250, I mean 10 inch. Oh, I'm sorry, it's showing the spacing in meter. Actually, it's showing spacing in meter. So that spacing should be in millimeter actually. Okay, I'll just close that. Now I'll go in unit and I'll click matrix default, then okay. Now I'll go for display slab design. Now the spacing showing in millimeter. Okay, so I'll just see A and B layer both, and for top river and 16 300 spacing apply. Okay, when we have applied, then see here, it's showing the requirement of reinforcement top for top. Okay, and here if we go 250, it's decreasing. Actually, if we provide reinforcement in top, okay, and we know that where we require, if we use that option, okay, if we use that option, then apply, then it's showing us at which point we require reinforcement. Okay, for top. Okay, for top, at which point we require reinforcement actually. Okay, so by using that option, we can provide the reinforcement only for that point. Actually, only for that point we can provide reinforcement, and that will be very economical. Actually, we're seeing that for every point in top, they have no requirement of reinforcement. Okay, they have no requirement of reinforcement here. That's why we can provide reinforcement only that point where the top bar are required. Now I will just remember that point, that point, that point, that point, and that point we require some reinforcement, and what will be the spacing of that, we can find out that by using topical uniform reinforcing specified below. So here 16, it's not okay. So if I go here 150 mm with bar is 16, it's also required some reinforcement here. So if I go here 100, apply, even we required some reinforcement here. So if we increase the bar size 18 mm, apply. Now see here, almost done, and also if we increase the bar size in 200 millimeter, then see here it's okay. So if we provide some extra reinforcement in top where required, just you have to remember that at which point we require reinforcement, then we can provide the reinforcement. Then 20 millimeter at the spacing of 100, right? Now our top is covered. Now we'll go for our show bottom bar. I will just uncheck our top, then click apply. Now it's showing our 20 mm bar with a spacing of 225. It's showing the reinforcement requirement. So I'll just give here 150, apply. Now see here it's decreasing. Again I'll go for 125, then apply. Here also okay. So if we go for 100 with 20 mm bar, now see that for 100 with 20 mm bar, or every point have covered the reinforcement requirement for every point that have covered. Just we have to provide some extra reinforcement in that column, around that column. Okay, so around that column, what will be the reinforcement spacing? Suppose first of all we'll provide spacing reinforcement at bottom with a spacing of 100 millimeter for with bar of 20 millimeter. Okay, and here we will just provide some extra reinforcement around that column. Okay, around that column. So from that pile to that, middle of that pile to that pile, middle of that pile to that pile, and middle of, so with respect to that square box, we'll just give some extra reinforcement. So how will give? See, if I give her go here for 80, then apply, it's not okay, then 50, apply. Now just see here, 60, it's okay also, then 70, 75, then we record some reinforcement here, so it's okay with 70. So just see here, we'll provide for bottom reinforcement everywhere. For bottom reinforcement, we'll provide reinforcement with 100 mm spacing for bar number, 20 mm bar, and for that around that column. Okay, from that pile to that pile, middle of that pile to that pile, middle of that pile to that pile, with that distance. Okay, with as like a square circular shape, will provide reinforcement, and will maintain spacing 700. Okay, I mean will provide an extra top and extra reinforcement between the main bar from that point to that point. So in this way you can make your detailing also. So it's okay, and with that video I am just going to finish our CSSA 2016 tutorial series, and I have created almost 47 lecture. And if you think that they have any issue and they have any problem to understand you, and I have make any mistake, then please let me know. I'll try to cover that. And if you think that the total tutorial series was helpful for you, then please don't forget to subscribe to our channel and also press the bell icon for next update. And also like our video, share our video, and suggest our channel for your engineer friend, because without your support we're nothing here, and we need more support to grow our channel more and spread our knowledge and make our field better. So thank you very much. So still stay connected till next video, and don't forget to leave a comment, and please like our video, because your own comment and your own like inspires for the next work. So thank you very much. In next I'll again come with another interesting and important tutorial series. So thank you very much.